Okay, we're back here today. Look at the difference of two squares, it looks like. Let's see what they give us. It says if x plus y times the quantity x squared minus y squared is equal to 0, which of the following must be true? They give us some options here. So go ahead, give it a shot. We'll come back and we will solve it together. Alright, so we're back, full disclosure here, this is the last question in a test, so this would be considered difficult. And as many of you know, when we one thing we like to try to do when we see variables, when we see letters, is try to stick some numbers in there, which is not a terrible strategy. I think when you get on these fringe ones, when you get to these really, really tough ones, sometimes it's going to be difficult to get numbers that fit. And you might miss an answer here or there, so you got to be really careful. There's certain times, I think, where the algebra will always override plugging numbers in, and that one of those times for sure is if you can recognize the difference of two squares. And I would always just tell you, if you can recognize the difference of two squares here, you must try to factor it and go from there. One thing I think they might catch people doing here as well is trying to FOIL this out. But your instincts have to kick in. Once you start to FOIL, right, and you start getting x cubed minus xy squared plus x squared y minus y cubed equals 0, your instincts have to kick in here and say, let me look at that. It's definitely right mathematically, but where am I really going to go with that? That's not going to go anywhere. So you would be best to stop there, I think. So again, you have to just be able to recognize the difference of two squares and try to factor it. So we'll keep the first term, which is x plus y. And how do I factor x squared minus y squared? Well, it's just x plus y, x minus y, right? And that equals 0. So you can sort of see, obviously this is the same term, and then you have this term. Well, as everyone should know by now, right, when you factor stuff and it's equal to 0, you just set each factor equal to 0, right? If you had something like this, always try to think of stuff how you know it. Let's say I had this quadratic and I FOILed it, right, and I got x plus 5, x plus 1 is 0. Well, then what would I do? I would set x plus 5 equal to 0, and I would get what? X to be negative 5. And then I would set x plus 1 equal to 0, and I would get x to be negative 1. So either of those solutions would work. Well, here I'm just going to do the same thing. Because these are the same factors, it doesn't matter, it's just the same thing. I'm going to say x plus y is 0, and then x minus y has to be 0. Then I might not know what to do from there, and that's why, they give you answers, so you always just have a look, and it looks like, right, we have x on one side, y on the other, so I'm going to move the y over. X is negative y, I'm going to add the y there. X is y. Well, now I have sort of a dilemma here because, well, x equals y, that's A. X equals negative y, that's B. Well, it can't be more than one answer, so now, one thing that people will try to do here is maybe just take a stab and guess at one of them. But don't do that, don't panic. I mean, this is right. It can't be A or B because they look to both be right. So now just scan the answers. And it looks like they're maybe squaring or even cubing here. So let's square both of these. What do we get? Well, x squared, right? Negative y squared is really negative y times negative y. That's positive y squared, isn't it? And here you can simply see x squared is equal to y squared. So this looks good. C looks really good. If I cube a negative number, right, it's still going to remain negative. So if I did negative y cubed, it's still going to be this, which is not one of the choices. So it looks to me like that should be your answer. So the only takeaway here for sure, see the difference of two squares, you must factor it, and do the algebra from there.